Hi, welcome back to the shop. This is part 2 in the making of my Toolpost grinder. We already made this bracket which will hold the spindle here. We have to line bore this to accept the spindle, but to do that we need this mounting, this clamping fist. I already line bored that diameter to accept the spindle holder, and now we need to slit it so we can clamp it with two 5mm screws here. And we're going to use a slitting saw on a milling machine, and I'm just laying out my cut line. I prefer Dicam, the fast drying layout blue over a Sharpie, because the layout blue is more resistant against oils. And also it has a pretty funky smell to it. And to apply it I use a Q-tip or some blue shop paper. Yep, that needs a few seconds to dry. So now I'm using my calipers and a scribe to pull over my line. Okay, now I have a layout line that I can use for the cutting. When you make a clamping bracket like this, where you drill first and bore and then you slit it, there is always the danger that due to the stresses in the material, when you go all the way through with your slitting saw, the material releases some of its stresses and it binds on your saw blade, and that's something to avoid in any case, because most of the time the saw blade breaks when that happens. And to prevent that, I'm using this this brass plug which I will press into the hole, and when the tension of the material goes, it binds on this plug, not on my saw blade. So I can remove my saw blade and then I'll go to press out this plug. Okay, I have a 1mm slitting saw in the machine. I'm just eyeballing my scribe line. I'm going to split the line on this cut. First we're taking a shallow pass and then we go full depth. And of course some cutting oil. Okay, as you saw, there's just 1 millimeter left that I missed. I will go again. And we're through. Oh yeah, we are all the way through, and we cut slightly into the brass plug, so nothing happened. Okay, what happened in this case? The bracket didn't bind on my part. It got even looser, so the tension in the material warped the part slightly, so the bore got a bit looser. As you can see, I can push the plug out that I before had to press in, so everything's fine. I'm using almost exclusively these spiral tabs that feed the chips upwards. I use them by hand, and I'm using them also on the machine. I'm using a triangle file to chamfer the edges of the slot I cut. Okay, let's put in some screws. And test fit it. Oh yeah, that's a nice solid kicking bit. This is not going to move on me. I like it. Okay, I put the parts back on the lathe and I mounted it as it would be used. The bracket on the cross slide, top slide, and the mounting bracket for the spindle clamped in it. In fact, it's still loose. I need to align it in that direction and in that direction. First align it. I'm slightly tightening these screws and also this nut on top. Okay, let's run the indicator back and forth. It's dropping, so we need to go higher by a good amount. And don't drop the indicator off the part. Stay at zero almost, maybe half a division mark. So that's fine. Now we bring our indicator over in this direction and we will check again. Okay, that's also 0. I'm tightening this nut. I'm not yanking on the wrench, just pull it tight. And we still have 0 on the dial. Now we need to center the diameter of the part and to use my deacator. Okay, this has a dial indicator dial and a stylus down here that rotates, and the indicator itself is standing still. Normally you use these on the milling machine, but of course there is no problem to use them on the lathe to center parts. And what you do, you let them run slowly, and then you correct with your dials until the needle movement goes to a minimum. Okay, this is the minimum I get. Normally you can adjust this until the needle is not moving anymore, but I get the same reading on the front and back. It's the same reading, but on the height I got different readings. I got my dial here and I got it here. This is because my part slightly warped when I did the tick brazing, but that's no problem for me. For me it's just important that it's not way off. Changing over to a boring board that we used before. Running it through the bore. Clamp it up in the chuck. And I run my live center against it to support it. Extend the quill a little bit. Okay, you can see the tool bit here. This is the screw to clamp it, and the Allen key down here, that's the adjustment screw. When I turn it, the tool bit goes out, or it retracts. Of course it doesn't retract by itself, you have to push it back by yourself. Yeah. I'm going to set it up for a first cut. Okay, this should be our last pass. I did my final adjustment on the cutting bit and I'm shooting for a diameter of 27 millimeters plus minus 1/100 of a millimeter. So, okay, I'm not returning the cutting tool while it's rotating because of recutting. Our spindle here. Ooh, oh yeah. That's a perfect fit. I can't insert the spindle all the way because there's this pin protruding. I have to shape a keyway into this where this pin can engage. Okay, I've set the shaper up for the keyway shaping. I mounted my slotting tool holder with a 5mm wide tool. I put an angle plate on the table where I clamped the part against with 2 strap clamps. And now I'm going to shape the keyway down here. And there you have it, a blind keyway with the hole as its relief. And there we go. Now the spindle fits nicely into the bracket, and also into this mount and this hard point to mount it on the lathe. What's now left to be done is tap this hole with the metric fine thread and make a mount for the motor. But first I have to figure out how this motor mount should look like. It will be some kind of a bracket that also clamps on this ground rod and will have a mounting surface for the motor in front. And then of course we will have to make the pulley. And we have to weld or glue ourselves the polyurethane round belt. But that's for another day. Thank you for watching.